and I'm Anna Tuta, co-founder of Coinstelegram, and here our guest, here Zhang, who is co-founder of Scroll. It's a fast research native zkEVM Layer 2 solution, and it's widely supported by Ethereum Foundation as well. Great to have you here, yeah.
Thanks for having me, Anna.
So can you tell how about your background and how did you get involved into this space?
Sure. So I started working on the proof around 4 years ago, back in like 2018. And so my background is more in the intersection between hardware and the computer science. So the first project I work on is using hardware to accelerate the proof, basically using ASIC and GPU and FPGA to make proof faster. Because back then, like the biggest bottleneck of using the proof is a proof time, because you have very large proof overhead. And then, like when I'm doing this acceleration project, I find that the algorithm itself is even more interesting than hardware, right? Because you can magically compress a very large computation into a very succinct proof. So I'm really curious about how this works. So that's why I started more on the theoretical learning about like how the polynomials are constructed and how the proof are generated. So I did like half a year research assistant at University of Illinois with Professor Andrew Miller, and I learned a bunch of applied ZK stuff there. I read a lot of ZK papers. I'm really addicted to the technology itself. So that's why like I really went into this area. But back then I'm still doing more like pure crypto and ZK stuff, not related to blockchain or cryptocurrency directly. I think back in 2020, where I met the other two co-founders, and also like I began to explore the blockchain space, where we find that DeFi is really interesting because like people need transparency, people need censorship resistant, and like I have done some transactions on chain before, and I find that the gas fee is super huge at that time, and so it happens that what I'm doing like for the proof can be a magical tooling to solve this problem, because the proof can fit into this blockchain space really well, because the idea behind the proof is that when people generate the proof, and anyone can verify that, so you get this very nice public verifiability, because blockchain is like every node is running the same computation. Like you use this redundancy to be secure and decentralized. And using the proof, you can achieve this magically by just one people running the large computation and other people just verify, and anyone can verify. And also like what I have done before is that I have done a lot of theory and hardware acceleration. So I know that at that point, like the overhead of ZK prover can be solved through hardware and some advanced crypto algorithms. And also like zkRollup is considered to be the most secure scaling solution with the shortest finality. So that's why like we started this with the other two co-founders, and with Sandy and Haichen. And Haichen is more senior in like engineering. He got his PhD in University of Washington, and he had done several years of engineering work at Amazon, doing a lot of compiler and very low-level system building. And Sandy is more in the like business development and like operation and partnership, a lot of other stuff. So our like three of us met together, and we are all in the EVM community, and we think this scaling idea is really amazing, and we have very competent like background. Like Sandy is more on the non-tech side, and Haichen is more on the engineering side. I had more on the like ZK and the research side. So that's why we began to build this. And also at that point, zkEVM is considered to be impossible. Like all the zkRollup, also it's like people like that, but zkEVM is considered to be impossible. zkRollup can only build for payment and swap. So those are very application specific. And zkEVM, like people usually think, okay, so EVM is not designed for the proof. So it has a very huge overhead when you are generating the proof. But because I learned a lot of things in the space, and a lot of researchers are contributing to pushing this area forward. So I know that using this advanced crypto optimization, you can represent your EVM logic in circuit like maybe 1 or 2 order of magnitude smaller. So it's a like 2 order of magnitude improvement. And using hardware acceleration, like even if your prover may be run on CPU like for a day, but using like hardware, customized hardware or GPU, you can make prover like another 2 order of magnitude faster. So combining all those factors, your concrete efficiency compared with like maybe 4 years ago, it's like 4 order of magnitude faster, so which makes that really possible. So that's why we think it's the best point to really start building this and building a general purpose zkRollup solution using zkEVM. And also by chance, like I drafted the first like spec for or the design like high level intuition for how it should work, and I sent to Barry Whitehead at the Ethereum Foundation, and it happens that like he's also thinking of the next step for scaling, and also like he is also thinking of zkEVM, and he thinks, oh, okay, so we want to build this, you want to build this, and why not build it together in the open? And it aligns with our vision a lot, like, because we want to build with the community, we want to have this very open like technology development. I want to embrace the open source, and so that's why like we start building like 1.5 years ago with the PSD team at Ethereum Foundation, and like we are building this together and exploring, and really exciting to see that it's finally coming here and running on our testnet. And yeah, that's that's a very long introduction for how I went into space and how like we decided to start to work on this, and yeah.
Yeah, so you just announced upgrade to your alpha pre-testnet. So can you explain, like you launched your testnet just in August, and now like what does upgrade mean? How is it different?
Sure. So three months ago, we are really glad to announce our first milestone, which is our pre-alpha testnet. Mm-hmm. So that pre-alpha at that stage, it's designed for users, for the community, where we pre-deploy some applications like a fork of Uniswap, and the users can play with the pre-deployed applications through their very familiar like toolings and interface like MetaMask. And also users can experience like bridging between like how you move assets from layer 1 to layer 2, and then like withdraw back from layer 2 to layer 1, and experience how long does that take. So that's mostly designed for users. And we also designed 3 different explorers to be really user-friendly. So there is a layer 1 explorer saying layer 1 transaction, there is a layer 2 explorer saying layer 2 transaction, and there is a special rollup explorer where people can see clearly that their transaction is committed on chain. You can even find your transaction, which transaction is committing your data on chain. And also there is a like proof of verification where you finalize your transaction, and you can see your status through that rollup explorer. So that's mostly designed for the community from the perspective of users, and they can just play and give us more feedback so that we can like fix our UI and UX difficulties ahead of time and fix some small bugs. And like recently, before East Global, we actually make the another big announcement for the milestone of our pre-alpha testnet, which is not only for users, but it's actually an environment for developers. So developer can deploy arbitrary smart contract on our testnet. So it's already like zkEVM already live there with smart contract deployment. And what we can support is that we can support all the familiar toolings like you use on Ethereum layer 1, like for example, developer like Remix, Hardhat, and even Foundry, like very recent toolings which can compile your smart contract really fast. And we can support everything that EVM can support in a seamless way. And developers can port their code directly from layer 1 to layer 2 without any code change. So that makes it really easy. Like we have done some live demos like at East Global and also at the ZK community session, and which it's kind of boring because the developer experience will be exactly the same. Like basically what you do the same thing. It's just a network switching. And also we open this testnet to all the hackers at East Global, and they can deploy on us. And there are already several projects deploying on us. And we have a form which is scroll.io/early dev. And like if you want to deploy on us, just fill out the form and you can deploy. So that's a very important milestone, demonstrating that okay, so zkEVM is not just a story; it's coming true, and with smart contract deployment and the interaction. And so that's basically for our pre-alpha testnet. Yeah.
So how do you support compatibility, and how can projects on layer 1 migrate to your zkEVM?
Yeah. So for compatibility, among the smart contracts on layer 2, it's exactly the same as layer 1. Like because we are not supporting each application as a rollup, or we are not supporting application stuff, but instead we are supporting the EVM as a whole, where they share the same storage, so that when you are deploying 2 contracts, they can share the same storage, like the same transactions, and so everything is the same as layer 1. So that's how the compatibility on layer 2 is the same as layer 1. But for layer 1 and layer 2 interaction, you still need to deposit and withdraw, because it's separate separate account system. Like you have layer 1 account and you have layer 2 account, and you can have compatibility within layer 2, and you can have compatibility within layer 1, but not directly compatible, like where you call layer 1, call layer 2, back forth in one transaction. So yeah, that's how we achieve this, like using EVM circuit as a whole, and instead of application-specific stuff.
And how many applications do you have currently deployed on Scroll, and what type of applications are these?
Yeah, I think there are over 10 applications, but because we just announced, so there are we are still at the stage for supporting early developers, and I think after Bogota we have already received more many applications, and after Bogota we will have enable them to deploy. So in East Global, a lot of applications. There are some ZK applications, and but other applications are still NFT, DeFi, all those applications on layer 1. So I believe that in the future, as we move further and further, we talk with more people, there will be specialized applications on us. But at this stage, it's still early to say but we can support arbitrary type of transaction. Yeah.
And as well, currently, it seems like almost everybody releases zkEVMs, and there are Polygon just recently released the zkEVM hammers, and there are zk Sync, Stackware. So how is your solution different from theirs?
Yeah, that's a good question. So comparing with Stackware and zk Sync, both us and Hermes solution is bytecode level equivalent, which means we can support EVM at the bytecode level. So basically, it means all the developer toolings will be supported. You don't there is no so everything that you can support on EVM, you can support on us. It's not, we are not targeting at Solidity, we are not targeting at any EVM specific language, but anything around that. But for Stackware, I don't think they really want to go into the zkEVM approach. They want to build some more efficient virtual machine. So the argument is that this is not efficient. We want to build something new. And for zk Sync, they build something new, which is still not EVM, but they build a compiler using our VM to compile Solidity down to this virtual machine. So it's still targeting at a specific language on EVM, not the zkEVM at bytecode level. So that's the biggest difference between us, Hermes, and zk Sync and Stackware. So, but our argument is that we believe that only EVM can make it, because layer 2 is built for layer 1, right? So it's for solving scalability problem of layer 1. But if you tell layer 1 devs, okay, so it's congested and expensive, but why not just re-implement everything on layer 2? It doesn't make any sense, right? Because they want to solve this problem very urgently. So that's why we want to support the same environment. But for comparing with us and Hermes, I think there are some slightly technical differences here. So for example, I think we have deeper level compatibility, but they are also using some very magic approach to really simplify their implementation and improve the efficiency. So basically what we are doing is that we are reusing the client implementation of Ethereum, which is called Go Ethereum. And we make some modifications to that and use that directly to generate layer 2 block. So it can make sure that our layer 2 block, generating the block logic, is the same as layer 1 block generation, which, because we can inherit this implementation, we can inherit the client implementation and directly take the trace from the existing things here. And then we have a circuit to prove that the trace is valid. But for Hermes, they have to build their own node to process their transaction and translate to their own zk assembly code. But their compiling target is the bytecode, so which makes them also bytecode compatible. But still, there are some differences. For example, I mentioned the sequencer implementation and the concrete circuit implementation. Yeah, so that's the biggest difference. As far as the progress, I think we are as you mentioned, in August we released the first zkEVM testnet with a real live zk proof. Although there are some unimplemented pieces and which we use some documentation to just skip that part, but that's a one with end-to-end proof generation. People can see that. But for zk Sync, although their testnet start earlier, it's still no proof there, right? So it's still it depends on our definition for testnet. And now I think we reach a similar stage similar to Hermes, where we all support smart contract development and we support proof generation. So we are at a similar speed up, but we can all support similar things. Yeah.
And Ethereum as well achieved quite a big milestone last month, the merge, the transition from proof of work to proof of stake, and basically it as well should reduce the fees and make Ethereum more scalable. So how did it change things for you in Scroll?
Yeah, that's a good question. So basically, moving from proof of work and to proof of stake doesn't influence anything on the rollup side. It's just how you do this consensus, and a bigger important milestone is 4844 and dank sharding, which makes the data on chain cheaper. So because the problem for zkRollup is that we need to upload the data as public input, or as a part of the data is used for if our operator or sequencer go down, you can recover your account. And so the data on chain is really expensive. And if you have something like dank sharding, which you can have this special type of transaction and make your data cheaper, then it will make rollup cheaper. Because the Ethereum roadmap is around rollup centric, right? Or I believe that you are in Bogota, you know, like everyone is talking about 4844 and like how Ethereum is upgrading. So I think after those milestones, like zkRollup can be maybe 10 times cheaper, and because the data won't be too expensive, and you can aggregate like a huge amount of transaction into one sustained proof, and the verification cost will be amortized over the transaction, and also the proving cost is not as large as people think. So I think it will be significantly cheaper after that milestone is reached.
Yeah, and as well you mentioned your involvement into hardware, and that in Scroll you achieved the fastest prover with ASICs and GPUs. Can you explain more about that?
Yeah, that's a very good question. So still some people are misunderstanding that we are building ASIC, we are building hardware by ourselves, but it's actually some of the misunderstanding come from that I was the author of an ASIC paper for zero proof, but that's part of the academic work, like where I propose some architecture for making prover fast. But for us specifically, what we are building is that we are building a GPU solution, which is a general purpose, because a lot of people have GPUs, and we have built a very fast GPU prover solution, and also we built a private GPU cloud. Like we have like 20 provers running, and we built a private GPU cloud, and so that to support our early stage testnet. And so that's because we are still a software company, we are not building like ASIC at this stage. So we are just, but we have a ton of experience knowing like how the performance will be on ASIC, IPG, and GPU. And we believe that in early stage, GPU will be a better option because a lot of people have GPUs, and especially after the merge, right? A lot of miners, they have GPUs, nowhere to go. If they still want to stick to the Ethereum ecosystem, they can just generally improve, right? Do something more useful. And our roadmap is that a unique part of Scroll is that we want to support decentralized proof generation, which means we are not generating proof only using our own private GPU cluster, but it's only used for early test. And we will open this proof generation to our community where anyone can run the prover. Like we will open source our GPU prover, and they can just run the algorithm using a GPU. Or we are collaborating with several like hardware companies, and those are the key hardware companies. They are building ASIC, IPG, and like GPU solutions. They are building cloud, or so we are talking with them about like our bottleneck, what's their algorithm, and because our code is open source from day one, so they can run directly to see what's happening there and how to build better and better hardware. And so that's stage one. Like it's private, but we started this collaboration. And in stage two, where we open this, giving this early access to those partners, and they can test their product and see if it works really well. And then in stage three, like we open access to anyone. Like if you want to use their service, you can buy hardware from them. You can stake, because some companies are providing some proving as a service. And if you don't want to use the services, you feel free to use run our GPU prover. So we will believe that a huge community will be part of the prover community to provide something and make our network eventually more scalable.
And as well, can you share your thoughts on the current state of crypto markets?
Yeah, that's a good question. I usually focusing on building and research side. I think, are you talking more about the economic side, or in general the directions or future?
Both.
Okay, yeah. I think for economics, it seems like already in a relatively bear market, but it's a good time for really focus on building things, because there are no shit, people won't have scam for building some random project. I think it's a really good time for builders to build a really good project during this period, and we're actually one of them, building this product, and we want to provide this infrastructure which is very solid, cheap, and with fast finality, so that we are ready for the next round of market, and project can deploy on us. And as for the concrete direction, we do believe that a lot of people around here are talking about ZK, about rollups, even Ethereum is around rollup, and we believe that this is the future for scaling, how you really achieve scalability without sacrificing decentralization. And there might be some interesting directions around like just layer 2 scalability. For example, there like people are exploring, and even us are exploring this fractal scaling, where like people can build layer 3 on top of layer 2, and how to decentralize sequencer. So there are still a lot of things. And Vitalik also mentioned like this multi-prover vision, which can improve the security for rollups. Like maybe different rollups can even collaborate in some sense, where you have 2 proofs and for security. So I think there are still a lot of things which is interesting for both researchers and engineers to work on, and there is incoming like 4844 and really exciting things around Ethereum. So yeah, that's something which I really care about, and also like a lot of breakthroughs in ZK proving system, like the which can make that practically faster and faster, and there is the ZK hardware. So I believe maybe in 1 year, like we can see something which is totally different. Like it's a much more scalar world, and people are all using rollups and with very fast hardware, and everyone can run everyone is talking about not mining, but talking about proving something at home, and yeah. That's my part of my thoughts, but yeah, I'm like still like working more on the research. So.
And do you cooperate with any rollups, or do you plan cooperation?
Is it good?
Do you cooperate with any rollups, or do you plan any cooperation?
Yeah, so I think we are open to being the very universal layer 2 for Ethereum, and then like different other rollups can be layer 3 on top of this, because we believe that, for example, especially Starknet. So the vision is that layer 2 is the most general purpose and the direct scaling layer for Ethereum. So that's why you need to keep the environment to be exactly the same as EVM, so that people can migrate code very safely. And but for layer 3, you can build more customized environment. Like for example, Starknet has this really nice Carol ZK virtual machine. It's different from EVM. It's powerful. They can verify proofs on layer 2. And then like you have these customized solutions, which if people really want to build some novel apps, they can go there and have different like layer 3 SDKs on top of layer 2. So I think eventually it will be a system like this. So we are open to this, and we are talking with people and we are happy to share our technology for everyone to use, because everything we built is open source with a permissionless license. Like people can use that, and so we want to have a community, and like we are talking with projects for how to use zkEVM, how to run that, but it's still like under exploration.
I got it. And can you share some future plans for the development of Scroll?
Yeah, that makes sense. So our company next step is that we will reach, so currently we are at the stage of pre-alpha testnet. We will soon reach a stage for alpha testnet, which will be permissionless. So because in your pre-alpha testnet, people still need to register, and then like they can play with that. Although it's open to everyone, but still like you have some limitations there. Mostly bottlenecked by we didn't open this proof generation to broader community. Like it's still limited by throughput, and we're still in a testing stage. And very soon, very soon, I promise, like we will move to this pre-alpha, not pre-alpha, the alpha testnet stage, where it's permissionless, and everyone can directly use that and see our prover, and at that point, I think it's very fair. Like anyone can launch. We don't need to, like you have to gain our access to deploy. And then like after this stage, we will reach a stage for, as I mentioned, like we want to open this proof generation to everyone. It's called layer 2 proof outsourcing, because it's not mining actually. It's just outsources proof generation to parties, and then we just make that more decentralized and make this decentralized prover more permissionless. And then next stage is moving to the mainnet. So in the mainnet stage, we believe that it's after a very rigorous auditing. So like for example, they keep, as Vitalik mentioned, like they keep want to be bug free for quite a long time. Like regardless of which project, like regardless of what claim they make, that okay, multiple rounds of review or whatever, because it's so many lines of code, it's a so complicated system. At that stage, I think currently we have already been starting to making some auditing plan for auditing our zkEVM. We might also have multiple rounds of auditing. So the security is really crucial before mainnet. And also we need to wrap up the rest of the circuits, which like some pre-compels and something like that to reach the mainnet stage. And also we need to improve the performance a lot for making that like more efficient on mainnet, using recursive proof or some other ways to make that more make that better. So I think that's plan for the mainnet, like after this permissionless testnet, and eventually like after we launch mainnet, we have ecosystem, we will apply some research result to the current stage. For example, we are doing research around decentralizing the sequencer, we are around proof system upgrade, we are doing like a lot of things around like circuit optimization and some like new virtual machine design. Like we can see whether we can port some parts to our zkEVM to make that more like even more powerful than EVM. So that's part of the research like we are doing in parallel, and we will apply after we build our first product. So yeah.
Thank you for such informative conversation, and hope to see more and more applications built on Scroll.
Yes, thank you for hosting that.